Good morning, grade 8. Okay, let's continue with the laws of motion by Newton. I'll be giving you some examples. Let's have this example first. Okay, can you see my shared screen now?
Yes.
Yes, sir.
Okay, can you read, Travis?
A 3.5 kilograms papaya is pushed across a table. If acceleration of the papaya is 2.2 millimeters, what?
Meters per second.
Milliseconds,
Yeah.
meters per second to the left, what is the next external force exerted on the papaya?
Okay. The question there is, what is the net external force exerted on the papaya, which is actually again a 3.5 kilogram. That's the weight. Okay, and the acceleration is 2.2 kilometers per second squared. So again, the problem there is the net external force. So how can we calculate again the net external force?
Formula?
Yeah, what's the formula? The F net, the net external force.
I forgot.
Huh?
I forgot what it looks
Check
like.
on your notes. We had a discussion last meeting with this. What is the formula of the net external force?
I don't have the notes.
Huh? Though we had this a discussion last meeting with regards to this.
Yes, we
F
had.
net equals MA, I think.
Hmm?
F net
Is it
equals MA.
mass acceleration?
Okay, let me reiterate what we had discussed. Please take down notes. Okay, we had just discussed this one last meeting. Correct?
Yes, sir.
So the formula, please take down that F net or force, external force. Okay, net external force is equal to mass times acceleration, because again, there is a relationship between mass and acceleration. Okay, as you can actually observe in a symbol, okay, it is directly proportional to force, and force is inversely proportional to mass. Meaning to say that we can actually cross multiply, leaving what? Mass times acceleration. Okay, that's the formula. Okay, going back to the problem. Okay, let's go back to the problem. Okay, how can we solve? Again, the question in this problem, first and foremost, we need to what? Identify what are the given. Okay, let's take a look at the given. What are the given there?
3.5 kilogram
Okay,
papaya.
3.5 kilograms of
milliseconds.
papaya. What else?
It goes at a 2.2 millisecond speed.
That's the mass.
2.2 liters per second. Is that meters?
Or milliseconds.
And
It's milliseconds.
the second given there
2.2
is the acceleration, which is
2.2
2.2
milliseconds.
meters per second squared.
Oh, it's meters.
Squared. Okay, you calculate.
7.7.
Okay, substitute. Mass is 3.5
Kilograms.
times
2.2 meters per
2.2
second.
meters per second squared. Okay. It's equal to, what should be done next?
Multiply them.
Okay, multiply. So the result is, what is the result?
7.7.
7.7
Meters per second.
meters per second. How about the kilograms?
Kg.
Huh? How about the kilograms? Kilograms per
Second.
meters.
Per second.
Okay?
Square.
Huh? Meters, kilogram per meter per second. Square.
Squared.
You cannot cancel them. You cannot cancel them. You need to put it all. Okay?
Together.
Or, okay, how about checking them, the unit used? Let me share again my screen. Remember the unit used? Okay? Let's have this one. Kilogram per meters per second squared is equal to 1 Newton. Okay? Meaning to say that in our problem, we can actually convert it directly to Newton. Correct? Kilogram per meters per second squared. So this is equivalent to 7.7 Newton.
Newton. Is it
Towards to the left.
No.
Of course, because the direction, this is a vector quantity. So it has a direction. Okay? Towards or to the left. Okay? So the net external force is actually 7.7 Newton towards to the left. Because again, the direction is towards the left, to the left. Okay? So the result is, if you calculate the external net force, it is 7.7 kilograms per meters per second squared, or 7.7 Newton. That's the correct answer. Okay? How about this problem? Let's have this problem. I want you to solve this problem. Okay? I'll just type in the problem. Are you still with me?
yes?
Yes.
Okay. So the problem there is a 0.50 kilogram tennis ball approaches a rocket at initial speed or velocity of 25 meters per second squared. If it is in contact with the rocket strings for 0.005 seconds, okay, then rebounds at 25 meters per second squared, what is the average contact force between the ball and the rocket? Okay. Please take
I
note
don't
of,
know if my answer is correct, but I'll just.
okay, please take note of the question. I will give you 5 minutes to answer that one. Okay. In my clock, it's 10:44. We will resume at 10:49. Okay.
Excuse me, Chair.
Yes.
Can we pass it this tomorrow?
Come again. Can you pass the?
Can we?
Can you pass the what?
Chair.
Mm-hmm.
Chair, are we going to pass it tomorrow?
Pass what? What do you mean? The answer? No. I'll give you 5 minutes to do that. Okay. Since our formula is force, okay, external force is equal to mass times acceleration, and you already have the mass, which is 0.50 kilograms, you need to solve for acceleration. Right? Because you cannot actually see the acceleration there. What is the formula of acceleration? Diba we already done with acceleration before? What is the formula of acceleration? Acceleration is equal to the velocity thing that we had discussed last school year. This is a continuation.
Initial velocity.
Yeah, the VF. Okay. Remember the VF and VI? Travis? The final
Sir?
velocity. Remember those?
Remember like the initial velocity stuff.
Yeah. Final velocity minus
E-
VI or initial velocity over. Di ba we are already done with this?
Yes.
We already done with this. I am the one who discussed this topic. Acceleration is equal to final velocity minus initial velocity over
Right.
time. That's it. Okay, over time. So that's the formula of your acceleration. So in order for us to calculate the external net force, okay, we need also to calculate first the acceleration. Because again, the formula of external force or external net force is mass times acceleration. Correct? Okay, you do the calculation. I'll be extending the time. We will be having your answers at 10:05. Okay, take your time.
Rebound, teacher.
Come again, RJ?
What is rebound?
Huh?
Rebounds.
What do you mean? I cannot clearly hear you.
Like, what does rebounds mean?
Rebounds? Rebounds or bounce. Or bounces. Diba when you hit the tennis ball,
Playing
it will,
basketball.
yeah, it will rebounce.
It's like dribbling the ball onto the ground. It will bounce back to your hand.
Yes, that's correct, Travis. Are you all done? Okay. 4 minutes left. All right, are you done? Let's answer this one. Okay. Again, in answering scientific problems, we always start with identifying the given. What are the given there?
0.050 kilograms times mole.
3 kilograms.
50 kilograms.
Okay, the givens are the following. The initial velocity, oh no, yeah, the VI, which is, what is the VI there?
25 meters.
VI, okay. VI, which is
25 meters per second square.
25 meters per second squared. VI, it is
25.
25.
meters per second. Yes. Yeah.
Are you sure? The initial velocity is 25 meters per second squared. Correct. Per second squared. Let me copy this one. How about the BF?
I don't know. Probably 0.
I think also 25.
It has initial. So supposed to be, it has final. We started the motion.
25.
Correct? So it should have the final velocity after the initial. Correct? So what is the final velocity there? Based on the question.
25.
It is okay.
Okay. All right, chair. Teacher.
It is rebounds at 25. So the final velocity, contact with the rocket. What is the average contact within? Okay. Rebounds at 25. So if it starts with 25 meters per second, okay. Yeah, correct. The final VF or final velocity is also okay, based on the question, right? We are actually basing it in our question. If the initial velocity is 25 and our final velocity is 25 also, there's no motion there.
It's the
Correct?
same speed.
No, there's no motion because the object or that particular object is not moving because it is actually still the same from the initial to its final. Maybe it's decelerating. Wait. It is in contact with the rocket strings. This is the time.
So we divide it.
Okay, so there's a problem with the given. We cannot have this one. Why? Because again, we started with initial velocity, which is 25 meters per second squared. Okay, that's the initial speed. And the final speed is, let's change this one. Let's change the calculation. Let's have this one at 45 meters per second squared. Yeah, 45 meters per second squared. What is it? Okay. Do we still have time? Okay, we still have time.
Yes.
I will give you another 2 minutes to revise. It's 11 in my clock, or 3 minutes. 11:03. Let's change this one because again, your initial speed is 25 and then your final is also 25. So there's no movement then. Change it to 45 meters per second squared. Calculate the acceleration and again, calculate the net external force. Yes, it is. Is this like a tricky question or trick question? Actually, you need to analyze on the situation. You need to analyze on the question. Okay? And inform me, sure, there's no movement then. Why? Because the initial is 25 and the final is also 25. The body is not moving. Right?
Yes, sir.
I was confused.
Do you maximize the time? RJ already sent me. Okay, his calculation. And let's have this one. Okay. $11:03. Then we will continue.